Hello! Today we're going to be talking about interior and exterior angles of polygons, but before we do that, I'd like you to take a couple seconds and fill out this table with as many names as you know for polygons given the number of sides. So go ahead, pause the video, see what you can fill out. Alright, so let's check your work. You should have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, and pentadecagon. This one, the 15-sided polygon, might have been a little more tricky, but if you notice, penta comes from pentagon, with meaning 5, and decagon means 10, so when you put them together, that means 15. So, for any polygon that doesn't have these unique sides, we could call it an n-gon. Okay, so like a 20-gon or a 35-gon. That means it has the polygon has 35 sides. So as we use that information, you may want to have those memorized so that way you know how many sides each polygon has. All right, but as we move forward, we're going to draw diagonals in each of these shapes, and that'll help us to kind of investigate the interior angles of these shapes. So looking at this, we have a triangle. We should know that if our n is 3, we have 3 sides. Our interior angles, all of them add to be 180 degrees. Now, for this one, if we drew in a diagonal, notice how it creates 2 triangles. So since it creates 2 triangles, we'll have 180 degrees here and 180 degrees for this triangle. So all together, we're going to have 360 degrees. So that's if our n is 4, our number of sides is 4. If our n is 5, and we draw in our diagonals, and notice that I'm just drawing it from one vertex, it creates 3 triangles, so 180, 180, 180, which would give us 180 times 3. So 540 degrees. And then if our n is 6, our number of sides is 6, if it is a hexagon, you draw it in, draw in the diagonals. Whoop, that's fine. You'll have 4 triangles, so 180 times 4, which would give us 720 degrees. Now, if you notice, each time we increase our sides, it increases the sum of all the interior angles of these shapes. And hopefully you can see it's all being added by 180. You add 180, you add 180. So that means if we wanted the interior angle sum, so the sum of the interior angles, that is always going to equal 180 times the number of sides minus 2. So if you take a look, this one created 2 triangles, and we had 4 sides, n minus 2. This one created 3 triangles, we had 5 sides, 5 minus 2, and so on. So this will work for any interior angle. Now, if we wanted each interior angle, like if I told you just to find this angle here, our n is 6, so we would have to take the whole interior angle sum and divide it by 6, because all of those should be the same if it's regular. So what that looks like is 180 times n minus 2 divided by the number of sides. So let's take a look at some examples. It says, what is the sum, and I'm going to underline some keywords just so we know which one we're using, the sum of the interior angle measures of the polygons below. Well, if one is a heptagon, that means our n is 7, using our table above. So if n is 7, we want the sum, so we're using 180 times n minus 2. So we do 180 times n minus 2, and like we said, our n is 7, so 180 times 7 minus 2. So if we use our calculator, 180 times 7 minus 2 is 5, we get 900. So this means all the angles inside a 7-sided polygon equal 900 degrees. Okay, I want you to pause the video, try out part B. So we should get 1,260 degrees. If it is an anagon, our n is 9, so we do 180 times 9 minus 2. We should get that. Taking a look at number 2, it still wants the sum, but we're actually given the sum this time, and we need to figure out what the number of sides is. So this time we're looking for n. So we're going to take this and we're going to substitute it in for our sum. So what that's going to look like is 2,700 equals 180 times n minus 2. So from here, I want you to go ahead and solve, figure out what your n is. So I'm going to pause the video, you try this out. Alright, if you take a look, you should have n equals 17. You could have done it this pink way or the blue way, and I don't care which way you do it, you end up getting the same thing. But if you distribute your 180, then add your 360, divide by 180, you should get n equals 17. Or right off the bat, you can divide by 180, get that out of the way, so those cancel. So you're left with 2,700 divided by 180, which is 15, equals n minus 2. Add 2 to both sides, you get n equals 17. Okay, so taking a look at the next one, 1,620, that's the sum, equals 180 times n minus 2. So let's solve this one together, making sure we know how to do it. I'll do it the blue way, where we divide by 180. Since this is being multiplied, we can divide it out. So if we do 1,620 divided by 180, that gives us 9 equals, and what were we left with? Just n minus 2. From there, we can add 2 to both sides. So we get 11 equals n. Okay. Moving right along, flip the paper over. It says find the measure of each interior angle in the regular polygons below. So if it's an octagon, the number of sides is 8. We are going to be using the equation where it's 180 times n minus 2 divided by n, the number of sides, because we want each. That's the key word to look for if you need to divide by n. So here we'll do 180 times 8 minus 2 divided by 8. So that would be 180 times 8 minus 2 is 6, divided by 8, giving us 135 degrees. So that means each angle in an octagon is 135 degrees. Next one, decagon, n is 10. Go ahead, pause the video, try it out. Did you get 144 degrees? Hopefully so. If not, double check your work and what you put in your calculator. And don't forget your degrees, that's a minor error. Okay, taking a look at 4, given the measure of each interior angle, find the number of sides. So we're this time again looking for n. We're given each interior angle, so we have to set this equal to the equation we had above here. So it's 156, setting that equal to 180 times n minus 2 all over 2. Excuse me, all over n. So we have a fraction equaling a whole number. So to make our lives a little bit easier, we can put this over 1 and cross multiply. 156 goes with n, so we'll have 156n equals, and we can go ahead and distribute here, 180n minus 360. Okay, we need to get n by itself, so move over 180, n. So 156 minus 180, that gives us negative 24n equaling negative 360. I'm going to move this up because I'm not giving myself enough room. And then, to get n by itself, we divide by negative 24. Or you divide 360 divided by 24. So we should get n equaling 15. So that would be a pentadecagon if it asked for the name. Now there's actually another way to do this. So But actually, we're going to get there in a minute. Get ready. Okay, I want you to pause the video, try out part B. Alright, hopefully you got n equals 6. Double check your work, see if you did everything correctly. Pause the video if you need to. Let's take a look at number 5. So it says solve for x. Now x is an interior angle. We need to figure out what it is. But if you notice, the shape is not regular. All the angles are not the same. But that doesn't change our sum. The sum of the interior angles is still 180 times n minus 2. In this case, looking at our picture, our n is 5. 1, 2, 3, 4, 5 sides. So we can substitute that into our equation to figure out what all the angles add up to be. So 180 times 5 minus 2, which gives us 540 degrees. That means all these angles have to add to be 540. So when you set it up, you could do this 68 plus x plus 85. That's a 5, sure. Plus 103 plus 121 equals 540. So go ahead, simplify all those. 68 plus 85 plus 103 plus 121 gives you 377 equals 540. So you can subtract 540 minus 377 to give you 163 degrees. Okay. Da, da, da. Moving right along. Now we're going to talk about exterior angle sum. Now exterior angles, exterior means outside, so the angle's outside. So I want you to draw in these angles. Just extend the lines, extend the lines, extend the lines. Our exterior angles are here, right? That's one exterior angle. So what this looks like is if I had, I don't know, 100 degrees here, an interior angle, the exterior angle, notice how they form a line? This would have to be 80 degrees. Now if we filled in the rest of these, we know if it's a pentagon, like above, they have to add to be 540. So let's make our lives easy. Let's say this one's 100, and this one's 100. And this one's 100. 1, 2, 3, 4. Then like this one, 140. I know this is not drawn to scale, but if we did this, this exterior angle would be 80. They have to be supplementary. This has to be supplementary. This has to be supplementary. This would have to be 40 to be supplementary. And I want you to take a moment, add all the exterior angles together. Pause it, add them all up. Did you get 360? That is true. The sum of the exterior angles is always 360 degrees. The sum of the exterior angle, no matter how many sides it has, is always 360 degrees. Okay, but if you wanted to find each exterior angle, just like before, you take the sum and you divide it by the number of sides. Okay, so let's try it out down here. It says, find the measure of an exterior angle of each regular polygon. Round to the nearest hundredth if necessary. Dodecagon, 12 sides. So you want to find the measure of each of an exterior angle. So that means we want 1. We're going to use this equation. 360 divided by 12. And that will give us the measure of one exterior angle. So you get that. That's 30 degrees. This is an angle, so make sure you have degrees there. 26 again. Go ahead, try that out. And actually, why don't you try the other two out as well? Pause the video, try them out. So for letter B, you should have 13.85 degrees. Don't forget your units. For number 8, it wants you to find the number of sides, and the exterior angle is given to you. So you could have set it up like this, which maybe you did. Cross multiply, you get n equals 18. Or you can take the number of sides and do n equals 360 divided by your angle. This ends up being the same thing as what you did here. So this is a little bit easier. I would try that out. But otherwise, we are done. We'll take a look at another way to find number 4 in class.